Hello, my name is Steve Bowler, and in this video we're going to be taking a look at Border Gateway Protocol, otherwise known as BGP. We're going to take a look within BGP. We're going to be taking a look at prefix lists and why we would use them with BGP. We're also going to be explaining what prefix lists are. They are similar to access control lists, in which they incorporate a matching logic. And what's important with prefix lists is that we can go one step further and we can incorporate IP prefix or subnet mask information within one statement, multiple subnet masks within one statement. Whereas access control lists, you have to match the bit length exactly with the wildcard mask. But within a prefix list, what we're going to be able to see is that we can match several different subnets within one prefix list statement. So we're going to show you guys how to set that up in this lab and how to verify the configuration, and show you when you would use prefix lists. So what we have done so far and configured in this lab is we have the ISP connection configured. Pretty much everything you see right now out here in the GNS3 topology, we have all the interfaces set up on the routers, and we have BGP set up AS1000 on the ISP router. So AS1000 is the BGP autonomous system for the ISP router. And then we also have our neighbor statements pointing to customer 1 and customer 2. Again, we're running external BGP, eBGP in this lab. So now we're going to go into those routers, customer 1 and customer 2, and configure those routers. On customer 2, we have already set up the interface to the ISP. We have also already configured the loopback interfaces. So now what I need to do is set up BGP for customer 2, which is router BGP 200, which is the local autonomous system number on customer 2. Then we're going to peer with the ISP router. This is going to be an external BGP link, so we'll do the neighbor command 130.0.0.6, and then the remote AS of the ISP router, which is 1000. And as we can see, the BGP neighbor relationship has come up now. If I do a show IP BGP sum, we can see that we have a neighbor relationship now with the ISP router. So now I'm going to go into the customer 1 router. Under global config, we'll do the command router BGP 100, which is the local autonomous system number on customer 1. We're going to form an external BGP neighbor relationship with the ISP router, an AS1000, which is, so the command we're going to put in here is neighbor 130.0.0.2, and then the remote AS1000. Again, that .2 is the interface from ISP pointing to the customer 1 router. So again, external BGP neighbor relationships in this lab. So now if I do a show IP BGP summary, we have peered with the ISP router. So the next step is what we're going to do. The next step, we're going to go into the customer 1 router. We're going to advertise these networks into BGP. We'll do the command network 130 we're going to advertise the loopbacks into BGP with the 130.0.3.0 with the mask of 255.255.255.0. Oh, we forgot to go into BGP configuration mode, so we'll do the router BGP 100 command. And then under here, we're going to put the network statement. So we'll do network 130.0.3.0 with the subnet mask of a/24. And we're also going to be advertising our 4 network with a /30 subnet mask. So now if I do a show IP BGP, we can see these 2 routes in the BGP table have been added to the routing table. Again, that's known as being valid and also needs to be best, as we saw there. So under the ISP router now, if I do a show IP BGP, see that we have received the 2 networks from customer 1. So now if I do a show IP route, we also see those 2 networks in our routing table. We can test this with the simple ping 130.0.3.1 and we have connectivity. And also the 4.1 and we are successful as well. So the next thing we're going to do on the ISP routers, we're going to be showing you how to configure a simple prefix list, and you do that under global configuration mode. We'll do the command IP prefix list, and you can see that we can name it. We're going to name our prefix list to customer 1. So I know when I look at the prefix list on the router, I can easily identify where in the network they are being placed. The next statement, our option is sequence. Just like in ACL, the sequence will allow us to place the ACL on. If we go back now and do like sequence 5, the 5 will come in before the 10. That's what the sequence means. And then we'll put in here the permit statement of 130.0.3.0 with the /24 subnet mask. Again, with the prefix list, we only have to put in the /24. We don't have to type it out 255.255.255.0 like we would an access control list. What we can see is that we have 2 things now we can see, which is greater than or equal to or less than or equal to value. And these specify the prefixes to be matched. And we will show you what this means momentarily. What we're going to do now is we will go ahead and match greater than or equal to 24. And if I try to do that, what you see here is invalid prefix range for 130.0.3.0/24. So we'll put less than or equal to 32. So what this is going to tell us by putting this command is that it's going to match this network, which is 130.0.3. So So this network has to be matched, and then we're going to say any subnet more specific from a /24 less than or equal to a /32 we are going to allow. So anything from 130.0.3.0 to 130.0.3.255 is going to be matched with this statement. And we can, so what we're going to do now is we're going to tie this into our BGP configuration. We're going to tie this into our BGP configuration to customer 1. We do this going under BGP configuration mode, and we'll go under the neighbor, or we'll type in the neighbor statement and then 130.0.0.1, which is customer 1, and then we'll follow it up with the command prefix-list and then the name of our prefix list. In this case it is to customer 1, and then it's going to ask us, just like in ACL, how are we going to filter this? We're going to be filtering this incoming. So because these networks are the networks that are coming inbound from our customer 1 router. So now if I do a show IP BGP, you can see that I have these two networks. And if I do a show IP route, I can still see both of the networks. If I do a show IP prefix list, we can see the prefix list in which we just created, and then we can see sequence number 10. So any other prefix list entry we're going to put in there by default will go up or increment by 10. So the next one will be 20. So it looks like we're still learning the 4 network. So we try to clear the neighbor with doing a clear IP BGP. We'll do a soft clear. Now that we can see that the prefix list is in effect. Again, prefix lists, just like access lists, there is an implicit deny all. So now if I do a show IP prefix list, the prefix list of customer 1 in sequence number 10, we're permitting the 3 network with a /24 or less than or equal to a /32, in which this network that customer 1 has sent us matches this criteria because it is a /24 subnet mask. At the end of the prefix list, there's an implicit deny all. So what we are seeing is the 4 network is being blocked. So prefix lists are very, very strong, and we can set them up so that we can only allow in certain networks from our customers or from other routers or devices. You can see that we just implemented this on the ISP router successfully. So let's go now back under the prefix list. We'll do IP prefix list. Again, we're going to take the prefix list name, which is to customer 1. We're going to add a sequence, which is sequence 20, and then we are going to permit 130.0.4.0. But what I'm going to show you is how the greater than and equal to or less than and equal to logic works. we're going to set up our prefix list to not match this criteria. So I'll do a /24 greater than or equal to, and then we'll put in do a /24 greater than or equal to a 25, and then less than or equal to 29. So what this statement is meaning is that it's going to match any prefixes that are /25 bits in length, or anything between 25 and 29 bits in length. Anything outside of this range is not going to match. So this /30 by this logic should not match this prefix list entry once we apply this. So now if I do a show IP prefix list, we can see that we have sequence 20 now. Now I can go back in there again with the sequence. I can go back in there and add a sequence 11, 12, 13, 14, anything in between there if I need to add anything in between those two sequence numbers. So with sequence 20, it's got to be greater than or equal to 25 bits. The prefix has to be that in length, or less than or equal to 29. So anything between a /25 and a /29 that customer 1 sends us, we will accept. So let's go ahead and clear the BGP neighbor soft, and now what we can see is that we are still seeing the 3 network, and that is because the /30 does not fall between the 25 and 29. So let's go back in to the prefix list. The next statement we'll do, again, we're going to use the sequence option. We'll do a no on the sequence 20 statement, and we will change this to greater than equal to 25 or less than or equal to 30. So if I go ahead and hit enter, if I do a clear IP BGP on our customer 1 neighbor relationship, we'll do a soft clear and do a show IP BGP, and now you can see the /30 has been added or allowed through into ISP's BGP table and routing table. So once you understand the logic behind a prefix list, it is not too difficult to implement and to understand. A lot of people get scared when you start talking about prefix lists and how they're like ACLs, but if you have a pretty good grasp on ACLs, then prefix lists aren't too hard to learn. So with this being said, we have just successfully filtered our routes inbound to the ISP router from customer 1. So let's go back under the ISP router. We will now set up a prefix list to customer 2. So we'll put in to customer 2, we'll put in the sequence number of 10. We're going to be permitting 130.0.1.0/24 of any length. So we'll go ahead and hit enter. And I'm going to show you some more logic within the prefix lists. We'll name this sequence 20. We will be permitting the 130.0.2 .16/24. Again, with this statement so far, what this is saying is this is going to match on the first 3 octets, which are 130.0.2, which are going to match to the /24. And we can see, if we go to customer 2 and do a show IP route, they are sending us the 130.0.2.16/28, which is the loopback 1 interface. So this is going to match IP 17 through 30 within this subnet in this /28. So that being said, that's going to be a /28 subnet mask. So if we go under the prefix list sequence 20 and put in a greater than equal to 29, what do you think is going to happen? Well, let's go ahead and take a look at the logic in this case. We'll go under router BGP 1000 for the ISP. We'll do the, again, to apply the prefix list to a neighbor, we do that by doing the neighbor command and then specify our neighbor IP address, and then we follow that up with the prefix list option, and then we put in the name of the prefix list that we just created, and then we're going to put in the direction, which in this case is inbound from the customer 2 router to the ISP router. So we'll go ahead and do a soft clear on the neighbor. We'll do, again, whenever you make changes to an ACL, a route map, a prefix list, anything like that, we want to do a soft clear on the neighbor within BGP to see those changes, to make sure that those changes have taken place. So we'll do a soft clear on the neighbor, and now if I do a show IP BGP, if I do a show IP BGP again, we don't see any of those routes in the routing table. So we don't see any of those yet. Let's go under router BGP 200. Well, we have to advertise our networks. So we'll do that with the 130.0.1.0 with the mask of 255.255.255.0. Then we'll do the network 130.0.2.0, I'm sorry, 2.16 with the mask of 255.255.255.240. And that should do it for now. Now if I do a show IP BGP on customer 2, we see those 2 networks that we created in the BGP topology table. So now if I go under, I'm sorry, not BGP topology table, the BGP table. So now if I go under BGP, we are seeing only the one route, which is the 130.0.1.0, because this is the only route or only subnet that is matching the criteria in the prefix list. Remember, the prefix list to customer 2, the sequence number 10 is matching the 1.0/24 network. So that is why we are seeing the 1.0 network in the BGP table on the ISP router and being added to the routing table. Again, we want to emphasize that you are not seeing the 2 network, because we are matching, in this case, we are matching the 130.0.2 any mask that is which is greater than or equal to a /29. So again, in this case, a /28 is less than or equal to, or less than 29. So of course we are not going to be seeing this subnet being advertised or being allowed through the prefix list. So what we can do is go under the router BGP 1000. We'll do a no IP prefix list on the sequence number 20, and if we change this to less than or equal to a /29, this should match. What this is saying is any routes that we are seeing from the customer that is less than or equal to a /29, it will permit. We're advertising in this case a /28 from customer 2 to the ISP router. So this should match on that /28 by doing the less than or equal to 29. So you guys start to understand the logic. It's not very difficult to understand once you just think about what's going on. So this anything that's 29 or less, like a 27, 26, 25, will be matched by this prefix statement, which is sequence 20. The prefix list statement, sequence 20. Let's go ahead and clear the BGP neighbor, and we'll do a show IP BGP. And now we can see the /28 coming in and being advertised to the ISP router and added to the BGP table and the routing table on the ISP router. So this is the power of prefix lists, unlike access control lists, where you can only do one access list statement. You can only match one subnet at a time, per se. In prefix lists, we can match multiple links of the subnet masks in one statement. What I also want to show you actually, never mind. If I go back to customer 2, we will do we'll go into router BGP 200. We will advertise the network 130.0.10.0, which is loopback 10 on the customer 2 router. We'll do this. We'll put in the mask of 255.255.255.0. So now if we go back to the customer 1 router and do the same, and under BGP 100 on customer 1, we're also going to advertise the 130.0.10.0. I'm sorry. What we're going to see is customer 1 and customer 2 are going to both have the same network that they're going to be trying to advertise, that they're going to try to advertise to the ISP. What this can do is this can be devastating to the ISP network, because it's seeing two different autonomous system numbers advertising the same network, and we should never see two different autonomous system numbers advertising the same network. So that's what we can do is, within prefix lists, we can filter out these unwanted networks from our customers or from other routers. So now if I go ahead and hit enter on both sides, both the routers, do a show run on the customer 1 router, if I do a show IP BGP on customer 2, we can see the 10 network in customer 2's BGP table. If I do a show run on customer 1, oh, it looks like we advertised the wrong subnet. Sorry about that, guys. We put in the 1 network instead of the 10 network. So we'll go back under router BGP 100. We will do the no network 1. I'm sorry, no network for the 1 network, because customer 2 is advertising that, and then we'll do the network command for the 10 network. So now we can see the 10 networks being advertised on both customer 1 and customer 2. So if we go to the ISP router and do a show IP BGP, we are not seeing this network because our prefix lists have the implicit deny all at the end of them. So anything else that we're receiving from the customers, we are filtering with our prefix lists. We can take a look at this with a different command. If I ever want to see routes from one of my neighbors, the way we can do this, the way we can see routes that we are receiving from a BGP neighbor, if we want to see routes coming from customer 1, we'll put in the show IP BGP neighbors command on the .1, which is customer 1, and then we'll put in the routes statement. You can see that we are learning 2 prefixes from route customer 1. So why are we seeing those 2 and not the other one? Because it's being filtered. The 10 network is being filtered in this scenario. We can also look at the routes before they become filtered on the ISP router. The same exact command, except instead of the routes, we're going to put in received routes. So we're going to get this error that says inbound soft reconfiguration not enabled. Not a big deal. We'll go under router BGP 1000. We'll go under that neighbor, which is the customer 1 side, which is the .1, and we'll put in after that soft reconfiguration inbound. And we will also enable this for the customer 2 router while we are here in the ISP router. So now if I do a show IP BGP neighbor received routes, we can see that we are receiving 3 prefixes, but we see that we are filtering the last one, which is the 10 network, from customer 1. So very good commands to use when troubleshooting. I don't know how many times I've used these commands troubleshooting BGP problems. If I do this now for customer 2, the routes command is going to be after it's being filtered by the router, and we can see this by the total number of prefixes only being 2. Again, under here we're not seeing the 10 network. So now if we do the show IP BGP neighbor on customer 2 and look at the received routes instead of a routes, we are receiving 3 prefixes. We are receiving the 10 network now, but we can see that our router is filtering this 10 network. We can see that there's no caret next to this route, which means that it's not being added to the routing table. So very good troubleshooting information that you really need to know if you are dealing with any type of BGP implementation. And we can see that there is no /10 network in our router if we do a show IP route on the ISP router. So let's say that the 10 network we should be receiving from customer 1, let's go back under our prefix list for customer 1. Let's do a show IP prefix list. We'll do the command under global configuration because that's where prefix lists are created. We'll do the command IP prefix list to customer 1. We will name it sequence 30 or add sequence 30. We're going to permit the 10 network under the prefix list to customer 1 with anything less than or equal to 32. So any type of subnet mask that they want to send us within this network, we are going to allow with this prefix list statement. So now if I do a show IP prefix list, we can see the prefix list to customer 1. Now we have permitted the 10 network from being received from customer 1. So let's do a soft clear on the customer 1 BGP neighbor relationship. Again, the soft clear is not going to bring down the BGP neighbor relationship, just flushes the routes. Now if I do a show IP BGP, we are learning the 10 network with the next hop of customer 1's serial interface. If I do the command show IP BGP neighbor 130.0.0.1 routes, now we can see 3 prefixes learned after they have been filtered by the ISP router. So again, prefix lists very important for you to understand within BGP how they work. You have to have a very good grasp on this for your studies. We looked at how to configure, to verify the configuration. We also explained prefix lists. So thanks for watching this video, and I hope to see you guys in the next one.